Hey ladies and gentlemen, sorry I couldn't be here today, but here's what we're going to be working on today. Today we're going to be starting with the Pythagorean theorem, which you may or may not have seen before. So hopefully this is a little bit of a review. Even though I'm not here, I still want you to be on your best behavior, and I know that you guys are going to do great because you are all so awesome. So let's first start by talking about the Pythagorean theorem. So I want you to go ahead and write this down. This is probably the most important thing you're going to write down this week, all right? Get that formula written down. Okay, so the Pythagorean theorem basically just means a squared plus b squared is equal to c squared. So what that tells us is that if we take the square of each leg, it will equal the square of the hypotenuse, which is actually pretty cool. So we're going to be using this theorem to calculate missing values of sides of a triangle. Okay, then. All right, so let's take a look at what some of these look like. Now, when we're going through these today, I want two things from you. I want you to write it as a simplified radical, but I also want you to give me the decimal approximation. Okay, so I actually want both answers on your homework and on this note sheet as well. So let's go ahead and let's take a look at that first one. So we're given A and B, which means we're given our two legs. So I know that 8 squared plus 15 squared has to equal c squared. So now we're trying to figure out what c squared is. So we're going to kind of use some of the tools that we learned last week with solving equations to solve this. So I'm going to take this and I'm going to punch it into my calculator. I'm going to punch in 8 squared plus 15 squared. Okay, so try and find that squared key on your calculator. If you don't have a x to the 2 key, that's usually the squared key. If you don't have that, you're going to need to use caret 2. So hopefully you know how to do that. Now, we have c squared, and that's going to be equal to 289. So now we're going to take the square root of both sides. And that's something that's really, really important to remember. Remember that in order to undo a square, you have to take the square root. Okay, so to undo a square, you take the square root. So by taking the square root of c squared right here, that just gives us c. And then we have the square root of 289. Well, the last thing I need to do is I need to get that simplified radical for 289. So I'm just going to write that out. So I have the square root of 289, so I want to start looking for pairs. So I just start dividing it by some numbers to see what I can get. Well, I try 3, 3 doesn't really work. I end up finding that 17 works. In fact, 17 and 17. Now both of those are prime numbers, so I have a pair. So underneath my radical, I have 17 times 17. Well, because I have a pair and that completely gets rid of everything under the radical, my simplified radical is just 17. There is no radical because it's a perfect square. So you also could have done this by taking the square root. So when we ask for the decimal, I want you to go back up before you simplified your radical. So take this version right here, and I want you to take the square root of it. So the square root of 289 is 17. So our decimal approximation is actually just the number 17. I want you guys to try number 2 on your own. You should end up getting a perfect square again. So what I'm going to do is I'm just going to get it set up for you. So you have 18 squared plus 24 squared is equal to c squared. So I want you to go ahead and solve this. Take that squared, add them together, and then take the square root of it, and it should be a whole number here. Okay, you should have a whole number. Next, let's take a look at number 3. Okay, so now number 3 gives us A and C, which means we don't have our B. We're missing one of our legs. So let's go ahead and put that into the Pythagorean theorem. So here we have 10 squared plus B squared is equal to 25 squared. So right now I want to get that B squared by itself. So I'm going to subtract 10 squared from both sides. So then I get B squared is equal to 25 squared minus 10 squared. So I'm actually going to simplify that out. So I have 25 squared minus 10 squared. And that's going to end up giving me 525. So I get b squared is equal to 525. Now, to undo the b squared, I'm going to take the square root of both sides. Okay, the next thing I need to do is simplify down that radical. See if I can get a simplified version. So I'm going to simplify down the square root of 525. Well, I see that it ends in 25, so then I know that this has to be divisible by 25. So I take 525 divided by 25, and I end up getting 21. So I get a pair of 5s here, and this breaks down to 7 and 3, so that's not going to simplify. So you're still going to be using that stuff that you learned 2 weeks ago. Okay, so here's that pair. So my simplified radical is going to have a 5 on the outside, and then underneath the radical, it's going to have 7 times 3, which is going to give me 21. So I have 5 times the square root of 21. So now I want to go back up here and I want to punch the square root of 525 into my calculator. So you should have a little square root key. Those of you that are using the real person calculator, the scientific ones, if you hit the blue second key and then your squared key, that should give you the square root symbol. Okay, so just kind of look on your calculator. If it's written above the button, then you hit the second key. So when you punch that in, the square root of 525 is going to give you 22.91. Next, let's take a look at number 4. So again, I'm missing one of my legs on this one. So what I have right now is I have a squared plus 11 squared is equal to 21 squared. So now I'm going to simplify this out. I'm going to actually subtract 11 squared from both sides. Now notice when I'm subtracting, I'm not subtracting these two numbers until I actually square them. So I have 21 squared minus 11 squared. And this right here is what I'm going to be plugging into my calculator. So then I get that a squared is equal to 21 squared minus 11 squared is going to give me the square root of 320. So if you were to just plug that in your calculator, that's what you get. Oops, so I got that square root because we need to take the square root of a squared in order to undo that square. Okay, so now we want to go through and we want to simplify that square root of 320 just like we've been doing. Remember, when I see something that ends in a 0, I like to use 10 because that makes it easier on me. So then I have 5 and 2. Here I have 16 and 2, which breaks down to 4 and 4, which breaks down to 2 and 2. Sorry, that's kind of hard to read. I'm running out of space. So I have 2 pairs of 2's here. Now actually, don't forget that you have actually 2 pairs of 2's there. So I end up having 3 pairs of 2's. So I'm going to multiply 2 times 2 times 2, and that gives me 8. And then I still have that square root of 5. So my simplified radical is 8 square root of 5. Now there's a way you can check to see if your simplified radical is right, and here's how. So what we're going to do is we're going to go ahead and simplify the square root of 320 and plug it into our calculator. So plug in square root of 320. When you plug in the square root of 320, you get 17.89. If you want to check your answer, you could plug in 8 times the square root of 5, and you should still get 17.89. Okay, that's just something to think about if you'd like to be checking your answers. I want you guys to go ahead and I want you to try number 5 on your own. So see if you can get it all set up and then solve. Don't forget to give me a simplified radical and a decimal. Let's take a look at number 6 together. So for number 6, we have 2 legs again. So we have 7 squared plus 10 squared, and that's going to be equal to c squared. So 7 squared plus 10 squared, that's going to give me c squared is equal to 149. So now to undo that c squared, I need to take the square root of both sides. So then I end up getting that c is equal to the square root of 149. So I took 149 and I played around with it. I tried to divide some numbers. I tried to divide it by 3. That didn't work. I tried to divide it by 9. Well, that didn't work either. So I kept trying to divide it by different numbers until I got something that worked. Okay, and I couldn't find anything. 149 is actually a prime number. So my simplified radical is actually 149. So next what I want you guys to do is go ahead and take the square root and punch that into your calculator. So when you punch the square root of 149 into your calculator, you get 12.21. Now what I suggest you do right now is stop before you move on in the video and go through and look back at some of the ones that I calculated out for you. Make sure you can get those answers on your calculator, because if you're not, you're plugging something in wrong. So maybe ask someone around you how they're plugging in, or see if they can help you on your calculator, okay? Because you are going to be getting these wrong if you can't plug them in correctly. All right, so just be thinking about that as we're going forward. Now let's take a look at some of these if we're actually given the triangle. So now I have to figure out what are the legs and what's the hypotenuse. Well, here's a little hint. The hypotenuse is always sitting across from the right angle. Okay, so this right here is the hypotenuse, and the hypotenuse is my C value. So if the side that's across from the right angle is not given to us, then we don't know our C. The other two that touch the right angle, okay, this symbol right here means a right angle. Okay, so that means right angle. And the two things that touch the right angle are your A and your B. So now we're going to go and simplify this out. So we have 4 squared plus 8 squared is equal to C squared. So then we end up getting 64 plus 16 is equal to C squared. So then c squared is equal to 80. So now we're going to go ahead and we're going to take the square root of that, because remember, that's how we undo a square. So again, even though it doesn't say it on here, I do want a simplified radical and a decimal. So then we end up getting c is equal to the square root of 80. So we break that down, we get 16 and 5, 4 and 4, and then 2 and 2. So I have 2 pairs of 2's. So my simplified radical then is 4 square root of 5. Now I could type that in to get my decimal, 4 square root of 5, or I can type in the square root of 80. Either way, we should get out 8.94. Okay, so you want to be calculating this along with me to see if you can catch your own mistakes as you're punching it into your calculator. I'm going to go ahead and have you guys try number 8 on your own. Notice that the side that's missing is sitting across from the right angle, so we're missing our C value. Let's take a look at number 9. So for number 9, what I notice is we have the value that's sitting across from the right angle. So that means we have our C. Now the thing that's great is it doesn't matter which one's A and which one's B. So I'm just going to call this one A, but it doesn't really matter. This one's going to be B. So now I need to go ahead and I need to solve this. So I have 4 squared plus B squared is equal to C squared. Oops, sorry, 9 squared, because we know what that is. So I have 4 squared plus b squared is equal to 9 squared. There we go. So now I'm going to go ahead and I'm going to subtract 4 squared from both sides. And then I get b squared is equal to 9 squared minus 4 squared. Okay, so when you subtract that off, you get that b squared is equal to the square root of, oops, hold on one second. Get that it's equal to the square root of 65. Now, the square root of 65 breaks down to 5 and 13, both of which are primes. So we don't have any pairs. So then b, remember when you take the square root of a square, is just the square root of 65. So that's our answer for our simplified radical is the square root of 65. Then we want to write it out as a simplified decimal. So the square root of 65 is going to be equal to 8.06. And here's a way you can tell if you did it right. Okay, your two smallest sides need to be the legs. So whatever you get for this has to always be smaller than your C. Your C value always needs to be the biggest. If your C value isn't the biggest, then you did something wrong. And we're going to talk about that more tomorrow when I'm back. So let's take a look. I'm going to have you guys do number 10. So again, notice the hypotenuse is here, so we have our C value. So you have to think about what this value is going to be and how you're going to plug it into the equation. And we'll make sure we talk about these tomorrow as well, but do the best you can on your own right now. Let's take a look at number 11. So use the Pythagorean theorem to find the diagonal of this rectangle. Well, here's the cool thing. We actually have a triangle, if you look right here. You can take a rectangle and you can split it into two triangles, and that's how we're going to get the diagonal. So really what I have here is I have a triangle with legs of 12 and 5, and so I'm missing a C. So let's go ahead and use the Pythagorean theorem to calculate that out. So I have 5 squared plus 12 squared, and that's going to equal to C squared. Well, 5 squared plus 12 squared is 169, and that's equal to C squared. Now again, to undo a square, you take the square root of both sides. And here's the cool thing about 169, is it is a perfect square. You can break that down into 13 and 13. So my C is equal to 13. So I don't actually need two answers for this one because my simplified radical and my decimal are the same because it's a perfect square. It is a word problem, so don't forget to tack on that label. Okay, let's take a look at number 12. I'm going to have you do this mostly on your own. But what you're going to notice is we're trying to find that radius r. But again, you'll notice that here is a right triangle. So there's a triangle drawn within there for us. So let's just draw that out separately so we can kind of see it. Okay, so it doesn't have it marked, but there's our right angle. So we have 4 and 4, and we're missing this r value. So you need to ask yourself, does r equal c? Is it our C value? And how are you going to plug that into the Pythagorean theorem? So I want you guys to solve for R. Don't forget to label it with centimeters. Okay, so once you're done, please bring this up and politely ask the sub for your homework sheet. Finish up your homework sheet, and that's all you have to do today. Because of the sub, we can't do proficiency as freedom, but I will be asking the sub who works hard today. And if you're not working hard today, I will not let you leave tomorrow. So finish up your worksheet, and then you will have more flexibility, okay? So make sure you're doing well, or I won't give you that proficiency as freedom tomorrow. Thanks for listening, and I will see you guys tomorrow. I miss ya. Bye.